Well, hello everyone, and welcome to the panel on AI infrastructure based on some of the work that we did previously. And I understand this is third day already, right? So it's been a lot of conferencing, and you might be already going through a lot of sessions. So thanks for joining us in this one. For those of you who will be watching the session later, feel free to ask the questions, and we will try to follow up and answer as many as we can. You might notice that we announced that we will have Damien and Ian today, but Ian had a big event, as you might be aware. AWS had a huge event last week, and they've been all exhausted. It was a worldwide event, so we had to, he couldn't join us today, but that's why we have Richard Jones from Max Mine and of course Damien Cole from Communet. They will tell us a little bit about their background in a minute. But what I want to talk about today, and with Richard and Damien, and how the panel will be structured. Well, we talk about the panel is about AI, but to have good AI, to be able to utilize AI to its potential, we need good data, right? So we will need what kind of infrastructure and what kind of underlying data systems we need to support AI. And I would say that as a educational institution and education in general, educational researchers and practitioners, we came to this discussion around data and use of big data quite late, after other industries already started to use big data to great extent to inform their businesses and gain advantage of using big data. So, and also, I don't think that we as the education institutions, whether we talk about schools or higher education institutions, that we ever invested in data. So what we did over the last 10, 15, maybe 20 years, we invested in learning management systems. We invested in different platforms. We invested in all kinds of tools that we can use in classroom. What that actually means is that we started to collect all kinds of data about students and about learning. Whether that was really what we wanted, that's another question. When you talk about agriculture and use of data in agriculture, there is something that's called farm digital twin. But in those cases, and Damien and I talked about that last Friday with James Osby from the AWS. But what that means is that those who are dealing with data in agriculture, they measure what they want. They put the sensors where they want them, and they capture data as they want it. In education, we usually capture what we can, which is another problem. So what I would like to tackle today, and where I really need input from Richard and Damien, is how other industries use different data infrastructures, how other industries use AI, what's new, how they be leveraging big data across different sectors, and what can we learn and apply in the educational space. So, Richard, Damien, thanks a lot for joining us today. And if you don't mind, maybe you can just give us a brief introduction of what are you currently doing and what's your role in data?
Brilliant. Do you want me to start? I'll kick it off. G'day. My name's Damien Coyle. I from Communet. We're about 60 staff here in Adelaide. Do software development, DevOps, data ops, machine learning, and analytics. A big swathe of computing that we do, and we do it for different companies over different industries. So we work a lot in aviation and the medical and agricultural fields, and a bit in mining and manufacturing as well. I'm a AWS ambassador, and my skill set is AWS ambassadors are sort of professionals within AWS that have been recognised for either strong certification or a skill set. And my skill set, the area I love working in, is I'm going to loosely term DevOps, but it's the fields around DevOps, which include DevSecOps and machine learning ops and data ops. And those fields of it's really automating through code, and we're seeing that's sort of where my strength is, building infrastructure and frameworks to support things that provide the right tooling, the speed and automation to get projects up and running, no matter what type of projects they are, workloads in the cloud. That's sort of a bit about me. Richard, do you want to?
Thanks, Damien. Richard. Again, Richard, I can't thank you enough for joining us the last minute. So huge thanks for that again.
We've got to be flexible in this day and age. It's no, I'm happy to join. So Richard Jones, I'm from Maxmind. I'm the head of analytics and support. So our company is a scale up. So we've gone through the sort of startup phase. We're now in scale up. We're here in Adelaide on Green Hill Road, but we've got offices around Australia and South Africa. Roughly 50 people, give or take, with contractors. And what we do is technology for the mining industry. And we are vertically integrated. What that means from a data perspective, and I'm going to touch on what you said, Srecko, about capturing what you can rather than what you want. So we have our own loggers. We mount them on mining equipment, the big stuff, the 4-story high mining dump trucks and excavators and things. And we tap into all the sensors that are on those pieces of equipment. And we get the data from those. We have written our own compression algorithms. That data goes up to AWS. We use AWS for everything. And we process that data, run algorithms over the top of it to figure out what the machines are doing, where they are, and how well they're performing those jobs. And then we feed that data back to the mine site in a way that gamifies behavior and focuses on the most valuable levers to pull from a management operating perspective. And so we'll have, for example, a league where the operators come off their shift, they'll look at a screen and they'll see, oh, I'm number one for the safest, the fastest, the most productive, and they'll start to compete against each other. And we'll get them to compete on things that are most valuable for that site, whatever it happens to be. We've got a team of management consultants that come in and align everyone on site with a management operating system as well as to what things need changing. So data is pretty central to what we do. We have to deal with data from whatever we can get rather than what we want. And there's a lot of algorithms on top of that. So my team is essentially a client-facing data science team. And so I deal directly with everyone on the mine site, from shift supervisors up to the GM and CEO. And we meet their needs, whatever they happen to be, given that our product is not fully complete because we're, going through that scale-up process. And so we will write new algorithms, do ad hoc analyses, whatever's required to turn data into some valuable decisions and actions, not just insights. So that's what I do now. And I sort of sit between that client, our development team, sales, marketing, executive, and the board. Historically, I do actually have a history in education. I did engineering, mechanical engineering, math, computer science, and then I did a PhD for several years in aerospace, lecturing and things like that. And I moved into computational fluid dynamics. And so from an AI perspective, lots of tensor notation sort of stuff, and using large supercomputers. And I've moved around different industries doing engineering consulting, wind tunnel testing and simulations and things like that. So a bit of a generalist, but these days I'm doing a lot of data, a lot of analytics and insights.
Well, that's great, because then we can kind of draw on different perspectives and drive discussion the way we really need to go. Thanks a lot for this really nice overview and the introduction to what you do and where you're coming from. We hear a lot about use of data to transform industries, right? And that an AI, I mean, when I say, I kind of, in this panel, I will use the terms data and AI kind of pretty much in a similar way, right? I'm not saying that means the same thing, but just when we talk about using data to transform industries, we think mostly in a way how we use algorithms and AI to help us get most out of it. So do you have, can you tell us a bit about some of the best examples that you can think of using data to transform different industries or a single industry, whether you talk about mining or agriculture or whatever you might have in mind? Maybe Damien, we can start with you again.
Yeah, sure. So I think, from what I've seen, certainly some of these industries that are a bit more that have probably have had innovation at the core of what they do. They really have pushed the boundaries are pushing a lot stronger boundaries than perhaps education in this space. The areas I tend to be either where industries which can't make mistakes, or really are pushed at every corner to make sure the costs are kept low and the like. So in aviation, that's where I sort of started out, building applications that tracked fatigue of pilots, tracked the machines, tracked for predictive maintenance on planes, and sort of these are highly regulated. It's a highly regulated industry. So we've built tools that were all around trying to make sure that we couldn't stop a production line, or couldn't have a failure. So certainly you see this in mining and manufacturing as well, where the cost of failure is too high. You really need to have things that went well beyond people doing double checking to make sure that they could continue on. So tooling that basically did that kind of preventative checking, and even now we're starting to see a lot of work in computer vision to try to detect things that we physically could be going wrong in a production line. So one of the projects working on is similarly in mining at the moment, which is to detect from cameras, CCTV cameras, anomalies in a manufacturing line, and to make sure that we can detect that early, put in some notification early when we see something is trending differently. So I think that kind of technology really has only, become affordable for many companies in recent years, but it's also become a lot more the easier entry point for many organisations to join. I think there might have been a very elitist kind of businesses that could probably participate in these markets previously. The only other one I want to point on is that agriculture. We've been long building tools in agriculture to track, to make predictions around the yield of a given crop. And some crops are very some crops are tricky crops. They are very focused around weather, very focused around the state of where they're at, and it changes dramatically how a business can operate. So even something as simple as how many people do I need out in the field today to pick these number of berries? How many berries are our berries ready for being picking or not? Sounds like simple questions, but they can actually differ dramatically based on the moisture in the air and how much how the temperature's been the last few days as to how much you're going to get out there. And you'll end up just be wasting lots of money if you end up sending too many people out into the field to do the picking versus under maximising your yield by having too few people available. So that's where we've seen a lot of the uptake in work we do, that using that data to answer really important questions. And this is a rostering question around how do you maximise the yield, because physically some of these fruits are still handpicked, very easily squashed. Handpicked things, you need physical people, labour in the market. How can you predict that and make sure you're reducing the amount of overheads that you have to maximise that effort?
No, thanks. That's amazing. So really interesting insights. I mean, at the end of the day, it seems like that some of the most, the most critical applications would be about around reducing risks and preventing issues. So yeah, that's really interesting. Richard,
I'm enjoying going after Damien. This is quite nice. I'm going to continue.
Are we going to switch that next time?
No. Please keep going. I'm going to leapfrog off of a couple of things Damien said. So one of them was early notifications. And that then led into him talking about ease of application and that being dependent on your industry. I think that's really key. And then what he led into was, what are the detailed drivers behind decisions that need to be made? And I don't mean that in the sense of a decision model in an AI system. It's more, how do we get the specialized knowledge from individual people and get that into a system where it's visible? The visibility of the detailed drivers behind someone's decision-making process is often what is wrapped up in the expert. The people that have been in a job for 10, 20, 30 years, they're very in tune with some of those nuanced details. And I think you've picked a really good topic here for this talk, which is infrastructure, because the ability for that infrastructure to measure or at least infer what those drivers are of those decisions is the enabler behind these different industries. The AI is the cherry on top, which is really nice, but the pain point in almost every industry is the infrastructure and the ability to capture or synthesize the drivers behind those decisions. Now, the early notification based on those drivers and the ease at which you're able to do that depends on your infrastructure setup. And I want to introduce the idea of the mandate from top down. And that's where there's so many differences between industries and between companies. I think prime examples is what Damien was talking about for agriculture. As soon as you start to get consensus in an industry and you start to get competition, that means that you're going to have a couple of things. One is some pressure. Pressure means that you're going to want to innovate and compete. The other is that you start to get cohorts of people that have that network of skills between industry specialist understanding and that domain knowledge, the ability to apply digital and data skills, and kind of that intangible, in mining we call it management operating system, the ability to tap into the decision-making process of an organization. So those are really key. I'm going to add a little bit here, which is that I think don't be too despondent or downtrodden about the education sector. You're not necessarily behind. There are a lot of industries and a lot of companies that are easily well behind where educational institutions are currently at. So you're by no means at the end of the bell curve. There are plenty of others, and I've recently had the fortune of being involved in an executive MBA overseas, and there were a lot of people from a lot of industries that they're very, very well-known companies, large organizations that are not ahead of the curve. So it completely depends on that mandate and the competitive landscape, I think.
I think now I will try not to talk too much to the points you both raised, because this is really touches to all the discussion points that we've been raising over the last several years and maybe even longer. A few things, right? Early notification, that seems to be common no matter where you work, whether you work in mining or agriculture or education. We all tend to seek for those early notifications of something happening, right? So for us, it would be around understanding where students need support and trying to identify whether someone is on track or falling behind, so you can help them early enough so that they wouldn't fail the course, right? So you just, where do you get data from to inform your decision-making process? Decision-making is actually really, really critical. When we talk about how we use AI to inform decision-making, whether we talk about that being how many people I'm going to send out to do the cherry picking or how I'm going to support my students, the key there I would think is deploying tools and on top of the infrastructure that would support whether we are teachers or someone in the production line, decision and sense-making processes. Because if we put something on top that interferes with the ways we work, we will never accept it. And that's why when you mentioned also, Richard, when you mentioned domain knowledge, top down and bottom up. So what usually happens in the educational institutions is that if you have top down, it's much easier to push for some of those changes. But the reality is, you usually rely on those heroes who really early adopters who want to push something and say, hey guys, this is amazing. And then 2 or 3 people might join the effort, but not everyone, right? So I totally agree that top down mandate. And I talked about that this morning here at the conference. I call that culture. We need to have that data culture, that we actually want to use data that's spread across the board. And we'll talk a little bit later about skills as well. But domain knowledge is really critical, because using data in education is not simply around crunching numbers. It's about linking those linking data to theoretical concepts, to educational concepts that we can actually use to inform teaching and learning. So that's why I'm really glad you touched on all those really important topics. Going back to AI infrastructure and data, right? So we have seen that the way we collect and store data has changed over the last several decades, right? So we came all the way from small databases, spreadsheets, databases, to warehouses, more recently to data lakes. If you haven't jumped on board data lake train 5 years ago, you're late, right? Now we have also data mesh architectures and similar. It seems like space is constantly evolving. What do you see as being currently the most commonly used or most prominent architecture out there over the last few years? Should we go again from Damien and then Richard?
Yeah, so you pointed to I suppose the questions we raised thus far are really, your architectures are based on the problems you want to solve. And I suppose your key point to some of those recent things, if we want to be able to make a prediction or make something that can provide, if we want to be able to make an effect, if we want our tooling to be able to give us decisions that are real time, the systems and infrastructure has to support that kind of real time aspect to the way we structure these things. So yes, we've had the evolution of to cloud. We've had that evolution to reduce costs, to have serverless tools that we can freely access, that we're paying for in a very different model than previously. Certainly the amount of data that we're collecting is considerably higher and continues to get considerably higher. And we've certainly redefined what data is. It's no longer something that's trapped away in a database for a line of business solution or whatever. It's we're now capturing images, we're capturing media, sound, all kinds of different types of things as well that we can report on. So it's all of those components that kind of come together. If we want to be able to do streaming inference, we have to be able to collect and receive data in a way that's unique. So the tooling we've seen infrastructure-wise, certainly a data lake model becomes pretty central just to keep the costs of these things low. But very quickly, the biggest issues become a governance-based problem. We've got data coming in, but if we have no idea who owns it, where it belongs, who has access to it, how long should we keep it? If we don't understand the risks associated with that data, we're in a lot of trouble. So we've seen other tooling that every company in this space uses a different name for it. We've heard the word lake house. I like to just use the word managed data lake. Something that has a bit of governance around a lake is what we've really seen as what you need to have that can both apply your business or organization's logic and governance piece around your core data lake. And you need to have ways in and out of that system that provides you with streaming data. Your systems have to feed it in real time as quickly as possible, and you have to provide ways and means in which you can give access to that data securely. And probably my point here is more that the other trend I see there is we've become a bit more cyber aware in recent even months. So many big moments where people are really poorly managing their data, no matter where it is, whether it's on premise or in the cloud or whatever. It's not that the tools don't exist for this. It's our data governance piece that we're not thinking about the risks associated with what we're collecting. Do we need to collect this data? Some data is not worth collecting for its worth, for its damage that it could be doing for you, and has limited value. So it comes back to what are the problems we're trying to solve. So and making sure that when we ask ourselves what we're collecting it for the right reasons, and we're asking the right questions of what value we can draw from it.
Well, I'm glad you mentioned that, because that's exactly what learning analytics and this research, educational research, should be or is all about. And it's about asking the right questions and collecting data that help us answer those questions. We know that the whole big data era started with assumption, let's just collect data. It might be useful at some point. Some data never gets used or never gets useful. So I'm glad that you mentioned that. Richard, would you like, is there anything you'd like to add?
Yeah, absolutely. I love how everything's named after a water body in data these days. There's the memes going around. You know, we've got data lakes and data swamps and a stream, and where's the estuary? Where's the pond? You know, I bet that's coming. Hey, I'm again, Damien's right on all counts. I'm seeing a trend towards cloud-based managed services. Obviously serverless, yes, but a managed service where, yes, it'll cost you some money, but the cost of that service takes away the cost of having someone in your team needing to manage a warehouse. I'm seeing that as a strong trend. And so opportunity cost is going to run through as a common thread through your decision-making process for your infrastructure. The opportunity cost for people versus the infrastructure and how you manage that, as well as what Damien said is what things do you actually measure. There's going to be an opportunity cost to that. Is the apple worth the squeeze? Another thing, the governance, I strongly agree with Damien on that. That is going to be critical. Where I want to join that in is, and this is, I'm going to draw a bit of a long bow here between a couple of ideas. That governance is critical because of the decision making that you're trying to do, as well as on a separate thread of thought, the ongoing management and capture of that data. So that's the opportunity cost bit from before. But if we talk then about who's using that data for a decision-making process, that's where I want to join the dot to real time. And certainly Damien's correct, in most applications, real time is really critical. But I want to introduce the idea of decision-making in an OODA loop. OODA loop is an idea from a military strategist, Boyd, from a couple hundred years ago. So the idea is to observe, orient, decide, act. Okay, so observe something, and in the military, it's the fact that your enemy's moving over there and they're about to cross the river, so you orient yourself around that. Well, the river's shallower there, and that means something to you. So you decide what to do. You try and outflank them and then act on it, you know, move over there and gun them down. Now, in the military, if you go around that loop at a faster frequency than your enemy, then you're going to win in the end, because you're reacting to the situation more quickly and deciding appropriately what to do. So I want to pick up on that because there's a couple of things in there. The first one is the frequency of that loop. Now, if you're trying to make decisions on a day-to-day basis in close to real time, obviously you're going to need a real-time system. If your decision-making processes are on a longer cadence, then the observation and orientation around that data set can happen on a slower frequency, and you take the heat out of the moment. So it is okay to choose your opportunity cost for your system based on that decision-making process. Just remember the fact that you made that decision, because in 12 months' time, someone's going to want to do it real time, and they're going to go, how come it wasn't set up like that? So keeping a record of decisions is important. Decisions on the infrastructure is important. Okay, then I want to tie that back into the cloud-based managed services. I'll give you some real concrete things. I'm seeing the combination of Snowflake being an exceptionally powerful managed service for data as an infrastructure. That combined with DBT, data build tool, for doing your extract, load, transform, which is the more typical one these days, together with some sort of governance tool, whether that's Atlan or there's 100 other different ones out there in the marketplace, and then an ingest tool of some variety to get your data from other systems. So Stitch, Fivetran, that sort of thing. Now, the ones I've just mentioned are of a similar vintage. They've all been made in the last, 5 years or so, depends on which one. And that means they've got a similar sort of philosophy about how they work. They're API first, they're cloud-based, they're managed services, and they're designed to hook into each other. And that might not be the case with some of your existing infrastructure, or where other people might have different ideas. So just pay attention to vintage when it comes to the combination of tools in your infrastructure.
Yep, some great points, and we have a question from Lee and in Zoom as well. But I will try to tie that back to the question that we're going to anyways, because I think it's kind of related. Richard and Demi, you also mentioned real time as something that's becoming critical. And to be fair, in educational research and practice, real time wasn't as much of a focus as it might be becoming, simply because what we are trying to do now after the whole COVID and everything going online, and we saw the technology can help us to some extent, but we need to push that beyond. So we are trying to use tools in the classroom that would help us get insights in close to real time, right? So it's not anymore that, yes, we're going to collect educational data and it's going to sit there for a week or two or a month or a year, and then we're going to build some models on top of that and use that in practice. That is the case. We still have a lot of that, but that real-time perspective is becoming more and more prominent in education practice and research. So basically, and the great question from Lee is on the security issues that we are facing these days, and Dave and I talked about this several times. What are the implications of moving your infrastructure to the cloud rather than having on-premise? So the question basically I'm getting at is what can these kind of infrastructure allow us in terms of access? Can we scale analytics? We usually have, when we build the infrastructure, we have one or several data sources in mind, but then we need to scale in additional components to it and maybe update our AI and the machine learning solutions that we deploy. Or it's about easier access to customers or students or teachers or whoever we talk about, right? So, or it's all of the above. So I'd like you to touch also on that security aspect as well. So what those kind of infrastructures allow us, and where is that security component, how that changes with these kind of approaches?
Yeah, if I could to kick that one off. I mean, the tooling for cloud. I've never encountered an on-premise scenario where somebody has almost as a more secure background than the tooling that is available in these cloud services. Cloud services have ticked off all the boxes and are now allowed to be used by very secure businesses. So, the FBI use AWS to store their most secure data. So there is no, in my mind, problem that the tooling can't do it, but there's certainly the maturity of an organisation is and we can't take our brain out of the jar and say, well, it's now a managed service. It's now somebody else's responsibility. In all of these cloud environments, all public clouds have a similar kind of principle. The AWS principle here is a shared responsibility model. Understanding what you're responsible for. The tooling for AWS, for example, if you store some data in a bucket in S3, you can decide to make that bucket open to the world. You can decide to make that data freely available. You can make it an open bucket, and that's one of the ways some people use that tooling. You're able to personally configure it that way. Having said that, a lot of people have these tools that make things so quick and easy. That has led to people just not thinking about it, creating a bucket, throwing some data up there, and not actually even registering whether their data was public or private when they came to do it. So what organisations need to do is take some responsibility here. There are some roles that in traditional IT that have existed to secure environments, and they haven't really understood the cloud environments very well to date. I think that maturity is where organisations are really focused around in these days, particularly with certain hacks and the like. Look, there are policies that can be applied and should be applied at scale that can overnight prevent data from leaking from an organisation through things like insecure environments, data not being encrypted, and that kind of thing. We can put in code now that remediates even data that was stored incorrectly and can actually go and encrypt it behind the scenes with a key that the organisation trusts. So we have the tooling there. It's the know-how of skilled engineers to be able to manage and oversee these environments. And that guidance, that individual guidance that says, look, here's our best practice. Here's what we want you to do. And when people actually fail to do that, you have policy to prevent stupidity as well.
That get difficult from time to time, but yeah, great point, Damien. Richard.
I'll extend yet again on Damien, and then I'll sort of add a little bit. So security know-how, absolutely critical. And what's important here is what Damien said at the start, is that there are standard systems now in all these managed services in the cloud, of having the user separated from the role, separated from permissions, and having those permissions linked directly to the data and what is accessible. So you might be able to filter out certain rows or certain columns of data based on the role that you happen to be able to inhabit. What's important to understand there is the power of the paradigm. And so the know-how that you need is about the paradigm. It's probably a more difficult job to do security for the on-premises systems because you need to know everything. The responsibilities haven't been separated between, is it the low-level hardware and access to systems or versus conceptualized restrictions like it is in the cloud. And so on-prem, you need to be across a lot of different things. Moving to the cloud, focus much more, in my opinion, on the paradigm of security and making sure you're using that paradigm correctly. And that'll get you a long way towards the secure situation that you need. Obviously, get advice. Obviously, go to the right people. But understanding the paradigm is critical. And the bit I wanted to extend on is that about 6 months ago, I learned from a friend of mine. He's the the head of strategy for the Fulton County school system in Atlanta, Georgia. And the security problems with data are immense for the school system there. And a lot of people don't realize just how important security is for data in education because of the consequences on that are acute. The immediate consequences of a data leak might be, about someone and their personal circumstances, their addresses, all of the normal sort of stuff. Then you've got the longer term consequences of data leaks from an educational center. So what are the learning challenges or perhaps mental challenges that some person might have? Is that in your data system, and has it been appropriately obfuscated from the data sets that some people are using? If that gets leaked, it might impact someone for a long time. These are issues that I never thought about until I talked with my friend about it. And so it really is critical. I sympathize a little bit for everyone on this who has to deal with security and infrastructure in education. But as far as the situation that you're put in to achieve that outcome, I believe moving more towards a cloud-based managed system is a good thing and provides that paradigm that you can leverage.
Yeah, definitely. I mean, when it comes to what we can share and what we cannot, and most of that we cannot, so it really links back to the protecting student privacy, right? So you can't easily share data. So it is really challenging to share data between institutions, even within the same institution. If you want to get something more from the demographic side or point of view, that is challenging. Of course, you have ethics boards who address some of those issues, but sharing is definitely one of the biggest problems. And we know from other domains, not just educational research, that open science framework have been pushed for at the moment. I mean, over the last several years, and it's something that really is there to support scaling of research and having insights across different domains. But it is still challenging to enable to push educational research at scale. So one of the approaches that we are currently working on is, can we actually use synthetic data to support push educational research a bit further? But that's another topic, right? So we talked a lot about different challenges and in deploying different infrastructures, and we are always going back to some of the most important ones, and being the culture and the top-down perspective, and then I guess access to expertise, and of course financial moment if we can afford such transition. Which and to be fair, we do transition to cloud in order to reduce some of the costs, but then again, the transition is not really, it doesn't happen overnight, so it's kind of process. So from what you have seen, what seem to be some of the biggest challenges in deploying infrastructure that we are talking here about? And I'm going to merge that with the next question. I think that Richard talked about that briefly earlier on the panel. What are the skills that we actually need to deploy and, more importantly, perhaps use such an infrastructure? So maybe we can start with Richard this time.
Oh, okay. I'm on the spot now. I can't just leave. I mean, we've covered a lot of this already. Skills necessary to deploy and utilize.
I mean, to make it more simple, so in terms of deploying the infrastructure, what do you see the biggest challenge? Okay, one thing is deciding, yep, this is what we're going to go. So once you decided that you want to go that way, once you decided that you secured the budget for that kind of effort, once you have everyone on board, what seemed to be the biggest challenge in making that, putting that in practice?
Well, I wouldn't discount the first part of that. I think one of the biggest challenges is people have come into data, AI, big data, whatever you want to call it, from different perspectives, different backgrounds. And so they may or may not be aware of the power of some of the latest tools. And the education process or discovery process for the broader stakeholders is really critical before, during and after getting that budget. There might be groups of people that simply don't believe that some of the capabilities that you're talking about are real and tangible. It is possible for some tools to appear to be good, and then maybe they don't live up to what they say on the tin. But more and more, I'm finding that the competition of business has weeded out those types, and big data is in these cloud-based managed services moving towards some pretty powerful tools that really are capable of what they talk about. And so the ability to get those new paradigms across and help other people discover those and go on that journey to realize what is really possible is almost more important than anything else. Then you've got the skills afterwards. How do you then leverage it once you start to get a mandate to work on these things? Personally, I'm finding it not too difficult with a baseline level of knowledge that people have from their teens in digital systems, coming up to speed on reasonably complex SQL queries, how to manage data systems. It might take a few months, but a focus on paradigm and the ability to use systems that are provided, as long as they're backed by the system, that will work.
No, sorry, I'm trying to, because I'm just looking, we have another 10 minutes left. So no, that's, and I would like to give another chance to Damien. Did you have anything, Richard, to add to this point, or am I moving too fast to the next one, or you're wrapping up? Are you happy for me to move to Damien?
So I'll probably wrap up that point by saying I have one data engineer on my team. He manages our Snowflake DBT analytics database for our entire company, and his focus for 7 out of the 8 hours in his day is on extracting, loading, transforming, not on managing the infrastructure itself. And we deal with mine sites across the world. We have 6 million hours of data on machines with per second data. So it's many terabytes of data with quite a number of parameters and sensors associated with that. And we can do that with one person. Obviously, there's a team of analysts and BI reporting people that hang off of it. But as far as managing the infrastructure, one person.
Yeah, I'm going to go back to this recording later on and extract this part. Thank you so much. It's a great point. Damien, yeah, Richard mentioned also good examples, and that seems to be common across other industries as well. So you need to have good use case to show that something works, that it has value, so that you can actually move for the adoption easier. Damien, anything that you would like to add?
Yeah, so I go back to, I think the 2 parts of the question. This first part of the question was what challenges with deploying solutions, I suppose, and I'm going with I think that's an interesting phrase. Deploying a solution is a good one, because we do a lot of experimentation in analytics, and I think this is where education has done extremely well. They're very good at researching a problem, but the word deploying is rarely actually considered in the upfront research. So it's more that, do you have the tooling there to build an end-to-end life cycle around the way that you manage your projects? So if the project has a goal of creating some insight or creating some notification, do you have the tooling around actually being able to physically go from one side to the other side of that starting with an experiment and taking it to deployment. And I think probably the other challenge that education has particularly is around funding, it can be very project driven. And the question here is around repeatability. Just because you've got a new project, you want to have repeatability in the way you work across projects. And building in that repeatability is actually the thing that I think is most important and the biggest challenge to a project, that you can actually have projects that continue to succeed and measurably succeed because you are leveraging same frameworks, same tooling across the board when you take on a project. You're not starting from scratch. I think the biggest issues around any AI or analytics project is you end up spending a lot of time back in the data munching area, data ETL phase, the ingestion phase, get the data, change the data, and you spend too much of that time. And been coined before that certainly, and I think this is a changing dynamic, but the challenge was that you end up spending 80% of the time mucking around with the data before you actually start doing the important stuff, which is finding insights from your data. And obviously that is the metric you want to be trying to reduce the amount of effort on when you're putting an infrastructure that supports this. The less time you spend having to tweak and deal with your data, and the quicker you can start building insight and deploying that insight is actually really, really important. And we talk about then the skills to support it. We have traditional administration kind of roles of data administrators in the past. They were good at querying data and managing the indexes behind data that make the data queryable faster and things like that. I think we obviously need to evolve some of these roles. Some of these roles sort of don't exist in this current format, or obviously have to take on a lot more nuance to how that kind of works in order to support modern cloud environments, data lakes and the like, where obviously my area now is all in automation. So every part of what I do is codified. It's repeatable. It self-automates as I put in a line of code and check that code in. It self-automates. It self-checks what I'm doing, that it's correct, and we'll go out and deploy the change to that environment, whether that's a new schema of a database or a new object coming into that lake or whatever. The whole thing is a scripted exercise. It self-documents the environment. I know who owns everything, who owns every part of that system, and there are sort of defined roles within that environment as well. So we want to be getting to the point where we can automate and have repeatability, and I think that will dramatically change the way we can get these things out to a deployed environment.
Yeah, so you pointed out a very important question here, and that's sustainability and how we make these kind of platforms not just ad hoc whenever we have a new project in educational research, but having that as something that sits there in the back. It supports our research and practice all through, and that seems to be that is one of the main most important aspects, definitely, because usually you kind of tend to when you run out of funding, you kind of struggle to support this kind of infrastructures. I just want to move to because we have 2 or 3 minutes left. I just want to point you into the work that Damien and I and our teams did on deploying an architecture that we call DAIR, Data for AI Research Infrastructure. And we did provide a link to the report position paper in Hua, and you can find the link on the top of the slide as well. It's basically how we see the role of this kind of infrastructure in deploying in educational research and practice. As you can see, I think we touched on most of those aspects in our panel today, from data collection to data repository to building different models. understanding what kind of data we collect and why we collect such data, and then deploying different kind of solutions and reaching back to teachers and students, but also problems such as monitoring, security, ethics, and other dimensions that fit under the governance. So I won't be, because we need to wrap up now, I won't be spending much time talking about this, but feel free to go and look into the report that we provided. Just 10-20 seconds from both Damien and Richard. How do you see future of data needs across industries, and maybe time back quickly to education, but don't have to. So how do you see future of data needs? Just briefly.
Real briefly, I would say enabling self-service. I think that's going to be a theme that continues no matter your job. Even if it's lower level managing infrastructure, you're going to be enabled to self-serve all the way through to the end BI user.
Damien?
Yeah. For me, the role of a data scientist, that is a really coined name for a reason. We've obviously started out in data just presenting whatever data we could get and throwing on a page and showing people, and people would say, yeah, can't make a decision from that. To a role where we are experimenting, we have being more thorough with what the value of what we're going to get out of everything we do from it, and that is a scientific approach to making sure that what we're actually presenting are good decisions that we're going to get back from it. The complexity will unfortunately continue to remain, I think, in this space. We're going to continue to have plethora of data that we're going to capture, and the problems probably that we're trying to solve are probably going to get more complex.
Definitely.
A lot of robotics and other kind of autonomous kind of things that we're seeing in different industries, and the ability to be able to, I suppose, finding that granularity between what we can do and what we should do is probably going to be a continual challenge to work out what we can use, for AI. What can we use it for? What should we be using it for? What shouldn't we be using it for? And I think those questions will still be things that dominate the next 10 years.
Yeah, I think this aligns nicely with the thought I had from a professional futurist the other day, and she said, Amy, she said that how the question was about how do you see future of AI and future of the world in general, and she said that I would like to see the future where we still have the agency, in the sense that we have data has been collected all over the place, but the final decision making should be again delivered back to us and should stay with humans, right? So thank you again, and thanks to everyone who attended the session live and who will be watching later. Again, I'm Srecko Joksimovic, and I'm from Center for Change and Complexity Learning at UniSA. We had Richard and Damien with us today. I'm going to link back to your affiliation as well. So feel free to reach out and ask any questions on Hua later on. The panel or Hua will be open for next 6 months. So feel free to reach out to us at any point. Richard, Damien, thanks again. Really appreciate your participation today. I think it was really nice. Thank you so much.